Hello folks, well I've got my Norwich City tie on, my Norwich City cufflinks, which must mean it's Friday and we're flying high at the top of the league, as I'm sure you're all aware. Anyway, just a little bit of feedback about the assessment that you've just done. Now I've had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of you have sent me in work that you did on it, which is great, but only 2 of you did what I actually asked you to do, which was to mark your work and give me a score, as well as putting in your own corrections and stuff as you go. So those of you who've done the test, that's brilliant, but if you could do that bit, it'll have 2 effects. One is when you go through and mark it, you will learn more from that experience about what you couldn't do and what will help you for the future. And then when you send me in your score as well, that will help me know more about how much more we will need to do on this when we all do manage to get back into school. Okay, great, thanks. So we are going to move on to a new topic now today, and it's a measures one, and we're going to start off with something quite basic of perimeter and area, and what is the difference between them, because people do get confused about it, and but hopefully you'll enjoy this. Anyway, let's move on. Now I've got some squares down here for a good reason. If you've got some squared paper, that's awesome, but don't worry if you haven't. And the reason is that area is all about the amount of 2-dimensional space a shape takes up, and that is measured in squares. Now what I'd like us to think about is not all rectangles are the same. Even if they've got the same area, what tells you whether a rectangle is bigger? How big its perimeter is, or how big is its area? To give you an idea of what I mean here is, let's pretend we're talking about a field that is 36 square meters, and let's pretend that one of these squares is 1 square meter. So I'm saying we've got a field that's 36 square meters and it's a rectangle. So rectangular field of area 36 square meters, and 1 square meter equals that. You can also write 1 square meter as 1 square meter like that, but obviously m with little 2 up there is a quicker way of writing that you'll normally see in maths. Now what I want to know is, how many different rectangles can you find if the length and width of that rectangle is a whole number? Can you find? So different ways we could make 36. You could have 36 times 1. Now I don't think this is quite wide enough, but long enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4. Oh, running out of space here. So if I go back 2 more there, this very long, thin rectangle is 36 square meters. But so the area equals 36 times 1, because the area of a rectangle is the length times the width. So it'd be good if you made notes of all of this. But the perimeter of this rectangle, perimeter is the length around the edge. So if you imagine that this is a field that's 36 square meters, what would be the length of fencing I would need to put a fence all the way around it if maybe I was keeping horses in there and I wanted to keep them all in there? Now these horses are not going to be very happy with this field because it's only 1 meter wide, so they can only sort of run up and down, but they might not even be able to turn around, so they'd have to run backwards a bit, so it wouldn't be a very useful field. The perimeter is going to be, well, we've got 36 meters long, haven't we, and 1 meter wide. So the nicest way to write this or work this out would be to add one length and one width together and then times that by 2. So 2 times 37, which is 74 meters. So the area is going to be the same for all of these, but the perimeter is going to change, and I want you to find as many as you can. So pause the video and see how many you can find, and then see if you agree with me. So I'm just going to carry on. You should pause it. So if I went 2 wide, 2 times 18 is 36. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And our area is 2 times 18 equals 36 meters squared. The perimeter is going to be 2 times, well, it's 2 wide and 18 long. 2 plus 18, so that's 2 times 20. That is only 40 meters. It's almost half the amount of fencing needed, and our horses can just about turn around now. They're still not going to be very happy horses, so maybe we could try what happens if we go 3 wide. Well, 3 times 12, 2, 4, 6, 8, 10, 12 is 36. So this is the same size rectangle in terms of area as this one and this one, but it's not the same size in terms of the length of the line I had to draw around it. That didn't take me nearly so long. So I've got a perimeter of 2 times 3 plus 12 is 15. So 2 times 15 gives me 30 meters. Right, keep on going. If you've just been watching up till now you might want to pause and see how many you can find. And actually, I'm not going to talk through all of them. I'm going to pause myself, write it down. So in a moment, it's going to jump on. Right, and this is the other two. There are only 2 more possible. So the 9 by 4 one, which gave us 26 meters, and the smallest amount of fence needed was if it was a square. A square is a rectangle of a special kind where you've got all the lengths being the same. So that gave us the smallest amount. Now, if I was a horse, I think I might possibly prefer this field here because I can run a bit further before I have to stop. But I've still got plenty of turning room. I don't know. I'd probably want a slightly bigger field than that. 9 meters by 4. It's not very big for a horse, is it? So maybe I should have gone with a bigger number there, maybe 360 or something like that. Anyway, hopefully you get the idea. So that's rectangles. We're going to move on to triangles next. Before we move on to triangles, though, actually, it's good to think about why these things happen. Why is it that as our shape gets closer to a square, we need less fencing to go around? Why we have a smaller perimeter? So have a think about that. When in the square, we've got most of the squares don't actually touch fencing at all. Indeed, we've got 4 squares which need 2 meters of fence, and the other ones around the outside only need 1. If you go all the way up to the other one, to our really extreme version, every single square meter needs 2 meters of fencing with it, and in addition to that, the end meters need 1, 2, 3 each instead of 2. So you get 2 times 36, which makes 72, plus your extra 2, 1 each for each end. So that's sort of what's going on there. These things become more interesting the more you think about what's going on. Right, so that was squares. Now, triangles, we're going to start with right-angled triangles. And the reason for that is all area stuff comes down to turning whatever you've got into a rectangle. The problem we get if I do a a triangle here that is 1, 2, 3. Yeah, let's make that. That looks all right, doesn't it? So I've got 6 squares along and 3 squares up the side. Now the problem I have here is I've got all of these bits here like that, which isn't a whole square, is it? It's not even a nice fraction of a square. I haven't drawn that very well, don't worry about that. So how do I work out exactly how many squares it would make? Well, I'm going to dot in for you here bit that would make up a whole rectangle going around the outside. So if it was the rectangle that we were trying to work out, it would be 3 times 6, wouldn't it? Now hopefully you can see that if this bit over here, if I shade this green, that this green triangle there is sort of upside down, but it's the same size as that triangle there. And it's for that reason that what we do to work out the area of a right angled triangle is we calculate the area of the rectangle, 6 times 3, and then say, but we only want half of that, so we divide it by 2. Now at this point I could do 6 times 3 is 18, half of that is 9, or I could do, because I've got an even number there, I could halve that one, couldn't I? And say that's the same as 3 times 3 is 9. But anyway, if we keep it at that, that might be simpler to think about. So 6 3s are 18, halve that gives us 9 square meters, if these are meters that we've got going on there. So let's write down what the formula is then. So the area equals the base times the height over 2. And strictly speaking, I should have said base times perpendicular height divided by 2. And that bit's sort of important because perpendicular, some of you will know what that word means, I think. Perpendicular means at right angles to, so the height at right angles to the base. So because we've got a right angle there, it works. If it wasn't a right angle there, it wouldn't work. So I'm now going to give you a few triangles, or just one triangle actually. This one's going to be very close, 3. So if we said it was 3 centimeters down and 4 centimeters across, I'm also going to tell you that that length there is 5 centimeters. I would like you to pause the video and work out the area and also the perimeter showing all of your working. So pause the video now, and now I'm going to go through it. So your area, it's the base and the perpendicular height. This is the right angle, so it's these two that are important. So base is 4 times height is 3. 4 times 3 is 12. Divide that by 2 gives you 6 centimeters squared. The perimeter is that length plus that length plus that length. So it's 4 add 3 add 5. 7 plus 5 is 12 centimeters. Right then, now it's time to move it on to any triangle. How about if I drew a triangle, so area of any scalene triangle, and scalene just means all the lengths are different. The lengths were different on the previous one, but it also had a right angle in. So if I had a base here that was 6 centimeters, and then I had if I had let's make it it's actually an isosceles triangle, but I'm going to have that distance up there is 3. Now, what I'd like to show you here is if I was to draw in behind here in red, can you see that we've got a triangle, a rectangle there that is 6 centimeters by 3 centimeters? And if I shade that in red, this red triangle is the same size as this one, and this red triangle is the same size as that one. So we've still got half the rectangle. So the area for any triangle is still the base times the perpendicular height which is the one at right angles there, divided by 2. And we can do this as long as we know that distance there, but it's a distance inside the triangle. It's not this length here. This might look like it's 3, but it's actually a bit longer because it's going diagonally through the squares 3 times. So that these lengths are actually a bit more than 3. But what's important is we've got a right angle, and therefore we can make it half of a rectangle. I'm going to draw a few more in here now. Oh, actually, just let's go for one more. What happens if I 1, 2, 3, 4, 5, 6? If I go there and then I go up 1, 2, 3 to there, and I make that my triangle, it's still 6 centimeters along the bottom, and it's still 3 centimeters on the perpendicular height. So it should still be 6 times 3 divided by 2, which is 18 divided by 2, which is 9 centimeters squared. Is it still half of that rectangle? Well, hopefully you can see that this red triangle is the same size as that one, and this white triangle here is the same size as that one there, which does mean it's still half the height. Now, what's quite incredible here is we can keep on with this idea, and it's still true if you go to that point there, or any point in between. Do you know what? It's still true if that right angle comes outside the shape. What the flip do you mean by that, Mr. G? Well, I'll tell you. What I mean is, if I was to do that, so I've still got a base of 6 centimeters to there, and I've still got a perpendicular height, so at right angles, of 3 centimeters. What would happen here if I drew the rectangle in is that we're covering up less than half of the rectangle now, but if I was to cut that piece off and then cut it up a bit more, I would be able to fill out that little bit there exactly with that. Now, it's not exactly the same shape, but that's because it's longer and thinner than this bit. And this is true. I could keep on going with this idea as far as I liked. If I grab a ruler and just let's do it just below here. If I was to do, there's my 6 centimeter base, 6 squares really, but hey. And then if I was to go all the way along here and go up 1, 2, 3, this triangle here because that's 3 centimeters there, is very, very long and thin, but it's actually taking up the same amount of area as all the other triangles we've done so far. that area is still going to be base times perpendicular height divided by 2, as being 9 centimeters squared. Okay, we just do a quick bit of practice of these with some perimeters as well, and then we'll call it a day. Right, so pause the video, have a go at these, and then this is a bit, if you're going to upload something for me, I'd like you to just upload this little bit with how you got on with a tick for everything you got right, and then if you've got another colour, put in your corrections to whatever I've done to help you when I've gone through that. That would be awesome. Thank you. So what you should have here, if we, it's area first, wasn't it? So the area is going to be 8 times 6, because that's the base and that's got the right angle on it, divided by 2. 6 eighths are 48 divided by 2, so that gives you 24 centimeters squared, and you get a mark for the 24 and a mark for the cm squared. The perimeter is just the distance around the outside, so 8 plus 10 plus 6, 18 plus 6 is also 24 centimeters. Only centimeters this time, because it's a unit of length, not area. If I call that one 1, that one 2, that one 3. So on to the second one. Your area is going to be 10 times the perpendicular bit is the 5 in the middle, which is 50 divided by 2, and half of 50 is 25 meters squared this time. So remember to give yourself a mark for the units and a mark for the result, for the number. The perimeter, we ignore the 5 because that's not part of the outside of the shape. It's the 10 add the 8 add the 6, and that is the same as we had before. It's 24 meters. Final one, we've got the area is going to be 20 times the perpendicular bit is the 6 divided by 2. 6 20s are 120, divide that by 2 gives you 60 square millimeters, and the perimeter will be not the 6, the ones around the outside. 20 plus 15 is 35, plus 9 is 44 millimeters. And that's our lot for today. Well done, folks. See you next time.